Good afternoon, everybody. I'm Maria Giovanna Masciotta, Assistant Professor from the University Gabriele D'Annunzio of Chieti Pescara. The work that I'm going to present focuses on the digitization of cultural heritage buildings for preventive conservation purposes. Particularly, I'm going to present you one of the protocols developed during the European project Heritage Care in order to show the potentialities offered by the combination of virtual reality, Internet of Things, and geographic information systems in the field of preventive conservation of cultural heritage. After explaining very briefly the motivations that have driven the project, hence this work, I will introduce the heritage care methodology with particular focus on the workflow followed for the 3D documentation and virtualization of heritage structures. Then, I will show the results obtained from the application of the developed protocol and associated WebGIS tool to two representative case studies, discussing the advantages brought by the digital revolution in capturing, managing, and processing big data within a tolerable time from virtually anywhere in the world. As you all know, cultural heritage buildings represent a significant part of our built environment. They reflect the historical layers of our society, and they are the most important physical evidence of the cultural development and diversity of the humankind. Moreover, beside their cultural and social importance, heritage structures and sites positively impact the economy of the cities and countries in which they are located, providing key touristic attractions. Though, following the Second World War, the maintenance of this heritage has been set aside in favor of the exponential growth of new constructions. Last disasters have also demonstrated that there is a clear mismatch between budget spent on constructions or large restorations and budget invested on maintenance. Actions do only occur when there is a significant visible impact on the structure, leading to overpriced reactive interventions. The key to prevent damages and minimize deterioration processes is to adopt a proactive conservation strategy, which means replacing belated and overpriced interventions with timely and affordable condition-based maintenance actions. To be effective and sustainable in the long term, such an approach must be rooted in systematic documentation and monitoring routines and must be supported by optimized digital workflows that can guarantee the integration, tracking, management, and longevity of a huge amount of heterogeneous information. The European project Heritage Care, Monitoring and Preventive Conservation of Historic and Cultural Heritage, coordinated by the University of Minho in Portugal, arose to answer these challenges, and I had the pleasure to work within this project as a part of the Minho team. In 3 years, Heritage Care developed and validated over 60 case studies, a preventive conservation system organized in 3 complementary service levels: standard care, plus care, and total care, whose main pillar is the systematic inspection and monitoring of the existing built heritage and related indoor assets. The quantity and complexity of the information collected about the conservation state of the inspected items increased along with the sophistication of the tools employed in each level, being progressively stored into a capable database accessible through a web platform. The standard care protocol aims at providing low-cost and rapid condition assessment of the heritage building by identifying its main damages and delivering in the form of an inspection report essential information about its primary conservation needs. The Plus Care protocol provides a more extended knowledge of the heritage ensemble by complementing and integrating information collected during the first level with an in-depth documentation of the building state, including detailed inspections of indoor assets, high-resolution surveys, and monitoring of relevant parameters, among others. Finally, the Total Care protocol integrates and manages all data gathered from the previous service levels through the BIM environment, allowing to support informed decision-making and to rationalize the management of the heritage conservation process. Focus of this presentation is the PlusCare protocol, whose implementation required the development of a tool able to blend together the latest advances in virtual reality, Internet of Things, and geographic information systems in order to integrate and georeference multiple and heterogeneous information coming from different inspection and diagnostic techniques, and to guarantee protocols interoperability. This tool, called the PlusCare system, converges into a dual web environment, namely one for expert users, inspectors essentially, and one accessible by non-expert users, like owners and facility managers. The main functionality of the expert user environment is to store all the technical information gathered through the application of the PlusCare protocol, namely asset conditions, panorama photos, monitoring data, point clouds, data records in general, and damages. To facilitate information transfer between technician and end user, the non-expert user environment features a friendly interface composed of 360 degrees photos of the inspected building across which the owner or manager can virtually navigate and access all the information uploaded by the inspectors and enclosed in the form of georeference hotspots. All significant information about the conservation state of the inspected constructions and related indoor assets are digitized, integrated, stored, and finally condensed into this visual output, which acts both as a supporting tool to address cost-efficient preventive actions, as well as a valuable reference source to facilitate screening activities over time. During the project, the PlusCare system was successfully applied to various heritage buildings across Portugal, Spain, and southwestern France. Here, I'm just showing you the results from two case studies: a large neo-Maronite church situated in Portugal and a small Romanesque church located in Spain. The former was object since the 70s of extensive visual inspections, monitoring campaigns, as well as topographic and geotechnical surveys to understand the origin of the severe structural cracks affecting the facade and their possible correlation with the tilting of the towers. It was found that the poor mechanical characteristics of the soil originated differential sediments that progressively led the towers to lean and the facade to crack. Hence, a few years ago, the church underwent an in-depth intervention aimed at restating its sound condition. The Spanish church was also object of a major restoration in 2011 that involved the enlargement of the foundations below the buttresses, the strengthening of the walls, and the cleaning of indoor assets, but no preventive conservation protocol was actually designed. Hence, both churches were included within the policies of the Heritage Care project. After a preliminary documentary research to collect all existing data about the churches, a systematic inspection was carried out by the Heritage Care team in order to digitally document the conservation status of the constructions a few years after the structural interventions. The mobile application developed during the project was exploited to drive the field work and allow a real-time digitization of the inspection process. Each damage was accurately documented and assessed, allowing to assist the owner in the prioritization of maintenance measures. This information was then integrated with the 3D documentation of the heritage asset as foreseen by the PlusCare protocol, with the aim of developing a virtual environment that could facilitate the preventive conservation tasks to carry out by the owner. For the case of South Orcato Church, a terrestrial laser scanner was used to perform the 3D digitization of the building along with the georeferencing of the damages. The tool allowed to obtain a very accurate 3D model of nearly 2 billion points. 174 scan stations and one full working day were necessary to accomplish this task. Then, the post-processing of the data required 3 additional weeks of work by 2 technicians. In parallel, a 360-degree camera equipped with fisheye lenses was employed to take panoramic pictures both inside and outside. In less than 2 hours, 42 panoramas were captured, and then both point cloud and photos were stored into the PlusCare system and used to create an enriched virtual tour through which the owner was given the possibility to interactively navigate and access fundamental information about the current condition of the church by clicking on predefined hotspots. For instance, information about type and location of damages, geometric details, asset conditions, and so forth. For the case of San Pedro Church, the 3D point cloud was captured by using a wearable mobile mapping system that allowed to obtain a 3D reconstruction of nearly 33 million points with a simple walk of 17 minutes, plus additional 17 minutes of post-processing. Alongside, the team acquired 17 panoramas, each resulted from a stitching of 7 images taken by a digital single-lens reflex camera equipped with fisheye lenses. The stitching process was carried out through an open-source software, investing 9 minutes per panorama. Then, also in this case, both point clouds and photos were stored into the PlusCare system to output a virtual environment based on 360 degrees panorama, linked to a geospatial database and enriched with meaningful information about the conservation status of the inspected church. Through the PlusCare system, each time new data is uploaded to the platform and georeferenced, new hotspots are automatically created inside the virtual tour and linked to the relevant information. Moreover, if a monitoring system is installed, real-time updates of the monitoring parameters can be displayed on screen together with the corresponding warning levels to assist the owners in undertaking appropriate maintenance actions. In the 2 case studies, the 3D documentation and virtualization of the heritage asset was performed using different geomatic techniques. This comparison allowed to highlight the advantages and disadvantages of each of them. Particularly, it was noted that the as-built 360 degrees camera is very small and light, but can efficiently capture and process panoramas in a short period of time, although the radiometric and geometric quality of the images results lower. As for the point cloud acquisition, the mobile mapping system demonstrated to be particularly appealing not only in terms of portability, but also in terms of time necessary for both data acquisition and processing. Yet, it must be said that the sensor has a centimetric, not millimetric accuracy, which is enough if no structural movements need to be captured, and shows some range limitations when it comes to high elements. In conclusion, I can say that the PlusCare protocol developed within the framework of the Heritage Care project rides the wave of the digital revolution and combines the latest advances in geomatics and smart technologies to document and track the conservation status of the heritage buildings in a systematic way, while ensuring accessibility and longevity of the information. Geomatic techniques and sensing technologies are pivotal for the digital preservation of cultural heritage, but they must be adequately selected according to the specificity of each cultural heritage asset and depending on the goal of the investigation. If you are interested, here you have some references of the work developed during the project. Thank you very much for your attention.